The purpose of this series is to make this and this perform like this. This here is a Nissan Sileighty. I've modified it specifically for drift, although I do a little bit of drag racing as well. It's been modified to have about double the factory power, and it's a couple of 100 kilos lighter too. I built it for drift, but I also like to drag race it. Best pass down the quarter mile, 12.6, even though it struggles for traction. Now this thing is also for drifting. It's called a drift trike. It's actually meant to be a kid's toy, although heaps of people on the internet get them and then modify them, normally adding a petrol motor to the back to make them slide a lot better. It's probably not that unusual for me to do a project that covers this. But this is where it gets interesting. This is a mobility scooter, normally used by the less able to be independent and maintain their quality of life. As they come, they're really not very fast at all. In fact, as soon as I hit the controls, there's quite a big delay before anything happens. And you can understand that. They need to make it safe so there's no nasty surprises. I think it would be hilarious and a whole lot of fun to modify this thing so it can also do donuts and drift like the other two. Now that you've seen all of the equipment, I'll talk you through the plan. Here it is, a cheap brushless 48 volt 1.8 kilowatt or 2.5 horsepower electric motor. I'm going to run it on 4 12 volt lead acid batteries that are 20 amp hours each. I calculate that as a theoretical maximum it's going to pull 37.5 amps, therefore the runtime will be somewhere around half an hour, but probably a great deal better. So what to do with the old electronics from this beast of a machine? Well, that's where the drift trike comes in. The specs are a lot lower. We're expecting about 0.7 kilowatts maximum, but hopefully it'll get the job done because it's smaller and lighter. Now I've already modified the tyres with PVC pipe as a proof of concept. Let's see what this thing can do. Okay, so you can see here I've put some PVC pipe around. It's a fairly simple process of letting out the air pressure, sliding it on, crowbar needed, and then putting up the air pressure and it locks it. First test is, will it get any traction to be usable at all? We've got a slight incline here. Let's see if it can make it up the hill. That wasn't meant to happen. Okay, looking good so far. If I can get traction now, then I know that when it's got a lot more power, just giving it a little bit of throttle, I'll actually be able to drive it around. And it's not happy. Yes! All right, so now we're on some smoother, flatter road, and we're gonna see if we can do donuts, because I think even with the limited power, with these type of sleeves, if this doesn't work, then it's never gonna work with a more powerful motor. So that was a pretty big success. I'm happy we've got a good platform for this, but there is one problem we'll need to address later on, and that's if I force it into a burnout, it's got an open differential. So it only spins one wheel instead of two, so let's test that out. You can see this wheel is going great, but on the other side, so rather than make a mess of the road, I think I've proven that the diff needs fixing, but for now, it's good enough. It's a little bit sketchy, but also gets traction downhill for the brakes. All right, so this one has made a pretty good debut, and I think the potential is there to do what I want. What I'm planning to do is to take out the 24 volt motor and all the electronics that slow it down, and that will leave me with a spare motor, which brings us to this one here. I think if I get rid of all the electronics and just use new batteries with the motor that came in it, with this light frame here, it should be really good for powering what I need. So let's see how it works without a motor. Well, really loose. Oh. Well, that went mostly well. I got a pretty big problem in that the top of this frame is loose. Can actually do that. So when I tried to pedal up the top of the hill, that happened. So therefore I tried to use it like a wheelchair to get it going. The other main problem is that because I'm so much bigger and heavier than a kid, all of the weight is over the rear axle. So as I try to pedal, wow, this feels very stiff. So as I try and pedal, I generally find I get wheel spin. That's if this doesn't bend. The main problem, however, is my bum. I've moved the seat back as far as the adjustment goes, but it's really digging into the side of me. So I'm gonna need to do something custom here. But apart from that, there should be enough room back here to mount motor and batteries. Remembering that it's only 24 volts, so I only need 2 batteries compared to the 4 that I'll need for the Mobility Scooter. Let's put this away for now. We are ready to start tearing this thing down and seeing what we're going to fit. I'm kind of in two minds whether I'm going to retain axles and components like that, or whether I'm going to try and move this whole assembly, since it works together, into the drift trike and do my own thing here. I'll have to make up my mind after I've seen what's inside. So let's get to it. Straight to it. Already we've found where the batteries are kept, and like I suspected, it looks like my new batteries are going to have to go either side of the seat. Doesn't really make sense to re-engineer things that don't need to be. So these batteries are only 12 volt, but they're quite big compared to my new 12 volt one. So I really hope that I can fit 2 per side and they go in the original position and it ends up really neat and tidy. All right, I have undone the batteries and we've got this nice retainer for them. Hopefully it's long enough to cover the 2 other batteries. If not, it should be pretty easy to extend it. Let's grab the handles and remove. Oh, there we go. All right, this is a nice spine. There's actually some foam padding because these are too small for the space available. So hopefully it definitely means the new ones will fit. I might measure them up pretty soon and check that out. You can see here the batteries are really close to fitting. They're just a little bit wedged. Happy to cut a little bit of that plastic away. Let's check. Oh, that's right, they are attached to each other. The length is pretty good. I think that's going to be fine for reaching. I'll probably need to extend it to make sure it's clamping down the outer battery a little bit. But apart from that, pretty good so far. I think as long as it's retained by this clamp here, it doesn't really matter if I end up trimming away some of this internal stuff just to get them to fit in the original place. Next thing to do is to remove this plastic cover that covers the motor and the rest of the axle assembly and see what's underneath. So here is the motor in all of its glory. We have the motor off the back with our 2 main positive and negative wires going in. And then this is a lock that decides whether you can push it by hand or whether the motor is controlling it. That's probably a handy thing to have on the replacement. I assume under here is a sprocket and a chain. It's really nice how it's all concealed, so I'll try and keep that in one piece to go onto the drift trike. And then this is our speed controller up here where the battery leads come in. Next job is to try and drop out this whole sub-assembly. It looks like there's 4 bolts and that should be pretty easy to do. There's a bolt on the other side that's spinning freely. Tell you what, there's something loose in this steering that I really need to address as well. Oh. Technically everything's disconnected, but I don't think I can get the assembly out without removing the wheels. So that's a bit of a pain in the bum, but let's get that done. Definitely do not want to lose this. This is the keyway, which is a little thing that slots in between the axle and the wheel to make sure it can't move freely on it. I'm going to put it back into position inside the wheel and make sure I don't drop it. Sounds bad. Probably help if I unplug these wiring looms. Would help even more if I actually disconnected the motor controller that's attached to the motor if I expect to pull out the motor. So I'm attempting to remove the loom in one go. It's getting pretty dark, so I'll probably have to finish up after this, but hopefully I can finally get this sub-assembly out with all of the loom connected. And then tomorrow will be super exciting because we can start to fit up the new motor. So here I am out in the dark. I've actually got the whole axle bit loose. I've stripped the loom from the whole front section. It's all ready to go. There's one bolt on the motor electronics that seems to be stuck and it's stopping me from pulling the whole thing out. Finally got it, had to drill it out, but here goes the final disassembly. Yes. Still works great because it's got the little skate wheels at the back to stop it from tipping over. So still 4 wheels on the ground. At the moment, it's an elaborate scooter, like a kid's scooter. This is a heavy old thing. Time to get it inside and connect it up to 24 volts and have a closer look. I have everything off the scooter. All the electronics are intact. Only one thing is not plugged in, and that is the light on the front, but that is fine. So let's test that everything works. I've got 2 of my new batteries in series to make 24 volts, just like the original. And I've got the throttle control here, which is normally controlled with your thumb or by pulling all of your fingers. Everything as it should be, including that annoying horn. And our key is switched on, so let's give it full throttle. Even under no load, even geared for torque, this thing, it seems very underpowered. So pretty keen to open this up. You would think it would just have a chain drive. Judging by the outside shape here, going from small to big off the motor to increase torque, but I don't know. I'll have to open it up and see. Oh, and did I mention it's filthy? It's going all over me and my room. So I've hooked up a multimeter to the output wires to the motor. Because it's a brush DC motor, there's only a positive and negative compared to the brushless one, which is essentially like 3-phase and has 3 controls. So let's see what the voltage ramp up is like and how long it takes to get to that full 24 volts. Okay, so I can see in my screen that it peaks at 22 and it takes quite a few seconds to get there. One thing I need to address is to probably change this motor controller to one that lets me pretty much give it instant throttle. If I'm going to have any type of torque to be able to spin the wheels and drift, then I'm going to need that. It's going to be an absolute must. Here's surprise number 1. The motor is actually completely separate to the transmission, or what I assume is just sprockets and a chain under there. So let's fire it up by itself and see if it frees it up, if it rotates any faster. Not exactly inspiring. After a bunch of mucking about, I've got the casing open and there's no chain and sprocket. It's completely geared system and it's almost like a worm drive here, and it's covered in gunk and it's filthy. I'm going to seal this one back up before it stinks at my house, and I'm going to need to go back to the drawing board. Welcome back. It is the next morning and I've been agonizing over this thing for hours. I've had some frustration and some breakthroughs, so let me talk you through what's happened. Firstly, the speed controller that came with this, it's actually worth about 270 bucks, but it's still completely useless for what I want because it's hard coded to have that really gradual ramp up of voltage. And what I'm looking for is instant throttle response. Otherwise, I'm not going to be able to break traction. Secondly, when I took off this end section, I think it's meant to be the electromagnetic brake. All of a sudden, I could activate the motor independent of the speed controller. So right now I have it connected directly to the battery and it goes like you would expect. The gearing is still really low, so it's not really ideal. It's going to rely on me being able to open it up and lock the 2 shafts, so it's effectively like a locked diff. Now I could do that by welding the spider gears shut, like some people do in cars, but for this I don't think it's going to be possible because the 2 halves need to be bolted together to mesh the 2 halves of the differential. So as soon as I unbolt it, it's not going to be touching, and therefore I won't be able to weld it. So might have to come up with some lateral thinking for that. I've ordered a brush DC motor controller online that's going to come with a throttle grip, and hopefully that will be suitable for the motor. It's just whether I can use this drivetrain. I've also ordered a complete subassembly for the rear of the Mobility Scooter, so that comes with an axle, hubs, wheels, sprocket, disc brake, caliper, foot pedal, everything. So hopefully that makes that easy. And in part 2, you can expect to see the brushless motor working and hopefully some fabrication. Hit that subscribe button and I'll see you then. G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.